I don't see any CRT TVs for ages, and then I get two within like 2 weeks, which is almost unheard of. But again, it's the vintage gamers with their little TVs for playing the old Pac-Man games and stuff on. Anyway, this one's dead. Let's see if we can fix it. I have here a little Toshiba 14-inch that was brought in for repair. Again, you get people that want to use these small monitors for old video games. This isn't even a monitor, this is a TV. So they'd have to use it with a VCR or an RF modulator. But these little sets are getting kind of scarce now, and people take what they can get. I mean, people are giving them away, right? So anyway, this one doesn't work. I'm told to have a quick look at it and see whether I can make it work. I told him, I said, listen, I said, you know, I got some small CRT TVs. I'll sell you if you want one. Bad enough. But he'd like me to look at this one and see whether I can get this one going. So I agreed. I'll take a quick look at it, and we'll see how quickly I can get this thing running, because I was pretty good at CRT televisions. So it's plugged in. Hit the power button. Let's see if anything happens. Okay, hear it click. Hear that click? So that's telling me that the standby power supply is working and it's energizing the relay. So I have to look beyond the standby power supply. So let's get the back off of this one and take a look at it. This one's using 1/4-inch hex screws. It just so happened that I have one of these. All TVs at one time used to use these type of screws. And then they migrated over more to the Phillips screws. This set is made in Singapore. Okay, let me get the back off this one, and we'll take a look and see whether we can figure out what's wrong with it. In the back, they actually have 4 different numbers that can be used for a picture tube to replace on this, like as if somebody would actually ever change a picture tube. I guess back in the day people actually did. I've never changed one on a set this small. I did change a number of larger picture tubes, you know, 25 and 27 inch, even some 32 and 34 inch monsters. I never changed one quite this small. Okay, first things first, I have to give you guys the warning. All CRT televisions work with high voltage. There's about 30,000 volts on the second anode. When I'm working around televisions or anything that's line powered, I always remove my watch, put it in my pocket, and I also only have one hand in the area of where I'm working. That's a rule. I keep one hand behind my back or one hand in my pocket. And I do operate always on an isolation transformer. That's rule number 1. Because this television does not have a transformer. Well, it does. It's there, the high voltage transformer. How these sets operate basically is you have a shunt rectifier or shunt regulator, rectifier and a shunt regulator, which is over here. This is going to limit the incoming voltage to about 130 volts, because when you rectify your AC on a 120 volt service here in North America, I know over in Europe it's a little bit higher, but here when you rectify your 120 volts, you end up with about 160 volts DC across the capacitor. So there's a resistor and the transistor, and it's a shunt regulator. So the majority of the current will flow through this resistor. In this case, it's this big resistor down here, and the transistor, the emitter and collector of the transistor, is placed across the resistor to provide regulation. If the transistor were to go open, the voltage would be low. If the transistor were to short, the voltage would be high. So there's only a portion of the actual current flowing through that transistor. The majority of it is flowing through that big resistor. Anyway, that's a little history on these sets. The B+, the regulated B+ on a set like this would be passed directly to the primary of the flyback transformer over here. Let's get some more light on here so you guys can see what I'm showing you. And typically how they operated is there would be a voltage that would be supplied from the standby circuit. These sets have, does this one have a standby transformer? I don't think it does. This one I think just uses a dropper to power up the standby circuit. That other little Mitsubishi set that I worked on had an actual transformer. This one doesn't. This one just relies on a dropper, a resistor or capacitor, and to charge up the circuitry. So basically the isolation for the antenna terminal is done here. So if I were to measure between here and the tuner, I should see infinite resistance because that is isolated by capacitor. And that's one of the reasons why you don't put video inputs on a TV like this, because the chassis itself is going to be hot. If I measure between the tuner and here, you'll see that it's, in the mega ohm range, 4.2 mega ohms. So this box here has capacitors in it that isolate the antenna terminal from the AC line. If I measure between a ground and the terminals, the AC terminals, the neutral line here, for example, get 1 mega ohm there on this side here. So we still got some isolation, but again, the power relay is off right now. What I'm getting at is the set itself is not isolated. The AC line is applied to one side of the chassis. It's a hot ground, and you could get a good jolt if you didn't have isolation on your input, such as the antenna input here. And if you try to modify and put audio, video, or component inputs on a set like this, this chassis here is not isolated from the line. It's a hot ground, you see, and you could get a good jolt from it. I operate using an isolation transformer, so I'm isolated from ground, but if you're plugged right into the mains voltage, you could get a nasty shock from any of the metal components inside here if your AC line was reversed, even though it has a polarized plug. So you should always have neutral on this blade here. If your wiring in the house was incorrect, you could have live on there. The TV would still work, but you'd end up with a fair bit of voltage on here. Much higher leakage than you would want, and enough to give you a good jolt. Okay, now that we've taken care of the safety, let's see why this TV is not working. There's a big warning sticker on the heatsink here to warn you that the heatsink is at mains potential, or high potential. It is connected, I believe, directly to the collector, if I'm not mistaken, of the horizontal output. If we measure it, if I look at the collector here, yeah, see? So this heatsink is directly connected to the horizontal output. So keep your fingers off it. It's not grounded, it's actually live. And this will have, when this set is operating, this will have about 1,000 volts peak to peak on it. It'll run at about 130 volts or so DC, but the horizontal oscillator, or the horizontal output, when it's running, will have a high voltage peak of around 1,000 volts. So it'll bite, believe me. If you get too close to it, it'll actually burn a hole in your skin, because it's operating at around 15.7 kilohertz. So first thing I need to do is I need to determine, is there any B+. So if I turn on the set with the relay, you'll hear it click. Okay, do we have B+? Yes, we do. We have 130 volts, 134 volts here. So we know that the power supply is working. But do we have any high voltage? Well, let's find out. I'm going to shut it off. First thing I'm going to do is I'm going to get my scope, and I'm going to connect my scope, and we're going to look and see whether we have any horizontal output. Because the first thing we need to do, you have to understand on these televisions that everything is derived from, this is the main transformer, right? All the low voltages for the TV, whether they're for the video circuit or whether they're for the audio circuit or the vertical circuit, everything is derived from the high voltage transformer. So there's a series of windings to give you 12 volts or 24 volts or or 16 volts or whatever is required by the rest of the circuitry. There are separate windings here, separate secondary windings on this transformer. So in addition to the high voltage which comes out of this lead, which is around 30,000 volts, and the focus voltage which comes out of this red lead here, which is typically around 10,000 volts, and this is the return for the high voltage, and typically the screen voltage, which is going to be to drive the output transistors, which is going to be around 200 volts. You've got all your other voltages off this. There's multiple windings. So this is the transformer on this set. I'm going to turn on my scope, and we'll look to see if we have any horizontal output or any horizontal drive. Had a little bit of a scare there. I turned on my scope. My scope didn't want to light up. None of the lights here by the buttons were lighting up, and these lights were lighting up. These were yellow. Right now there's only one of them that's yellow, but all three of these were lit up solid yellow, and none of these other lights were lighting up. I couldn't select modes. I had no display. I had nothing on the screen here, so I thought my scope was doomed. I shut it off, let it sit for a minute or so, and turned it back on, and it reset. I don't know what happened there, but we've got the scope connected to the collector. I figured, why bother checking to see if there's drive? Let's just check and see if there's output. So I've got it connected to the collector. I've got my setting to 5 volts per division, and I've got a times 10 probe, which is 50 volts per division. I've got my gain turned all the way down, because at 50 volts per division, this thing's still going to be off the end of the scale. This thing's going to be close to 1,000 volts peak to peak if it's running. So let's turn it on and see what happens. Oh, look. So I have a nice clean horizontal pulse. So that's telling me something very important. That's telling me that the horizontal oscillator is working. I might as well shut this off now because I don't need to measure it. It's telling me that the horizontal oscillator is working. It's telling me that the output transistor is working. And it's also showing me that there's no problem with the flyback, because that pulse was clean. If that pulse had distortion on it, there'd be a problem somewhere in the flyback or something. So now I know, okay, I've got power to my horizontal output. Set's off, by the way, now, and power's turned off. I've got power to the horizontal output. Probably still voltage on here too. Oh, there could be. I don't care. It's not going to hurt me. 0.6 volts. Not going to hurt me. I got power. I've got the pulse. We know it's got juice because I measured it before, right? It's got 133 volts. There's 1,000 volts peak on here right now, peak to peak. So if I touch that, I get a nice little RF burn from it. But we know that the signal here is clean. Yet the TV's not working. I got no sound. I got no picture. So, gotta be one of the voltages off of the flyback that's missing. Could be capacitor that's gone bad. Could be a resistor that's gone bad. I'm betting on a resistor, possibly a diode. So let's just turn the set over and look to see if there's any voltages coming off of the set itself. So on the bottom here we have a couple places that we can look for voltage. We'll probably use the scope again here in a minute if I need to. But we have there's different supply rails off of here. There's a 12 volt rail right there, and that's probably the first one I'm going to look at, because if the 12 volt rail is missing or low, the TV's not going to work. Now I could go dig up a schematic for this thing, but really I don't need schematics. I can work quite well without a schematic. Power on. TV is on. I can hear it running. If I measure there, I've got my 134 volts. If I go down here to this, where was it, 12 volt supply, and I've got 0.8 volts. So the 12 volt supply is dead. And it feeds in here through R449, it looks like. What's the voltage here? 0.8. This is going the other way. This also feeds in from, looks like it comes from this one here. 0.8 and 0. And that feeds. Okay, so this feeds in through this resistor. It starts out here. There's a coil L444. L444 is there. And then that comes back from C449, the positive side of C449, which has got 0. And that, I trace that back, and that comes back to this D408. This is going to be the rectifier. So I should see AC on this side. I'll switch my meter to AC. I got nothing there, and then there's this resistor R448. And I have 36 volts. And on this side I've got 0. What do you think that this resistor is open? I think the chances of that resistor being open, this is supposed to be 12 volts, but again it's at the horizontal frequency, so it's at 15 kilohertz, but it's not under load. Therefore, you can see it feeds right off of this pin of the flyback transformer right there, 36 volts. This one here has got 77 volts on it, and this rectifier here 28 volts, so that supply is good. There's our 28 or 27 volt supply. See, 27 volts is good, but our 12 volt supply is zip. Therefore, I think our 448 is open. Let's change it. Make sure that everything has discharged quite nicely. 3 volts, yeah, we're good. We're good. Let me turn on the soldering iron here. And we'll take this resistor out. This is probably a relatively low ohm, so I'm going to say it's a fusible resistor. We'll just measure it while I'm waiting for the iron to warm up. So R448 is measuring, yeah, a half a meg. So it's open. Where's the fun there? I didn't even get to use my scope. No fun. Good old regular snooze fest fixing this thing, right? Old solder. Just put some fresh stuff on there to make it flow a little easier. And here's the resistor I just pulled. Looks to be a 2 ohm resistor. Get a close up of that. Two ohms. I should have something, a reasonable facsimile for that, but yeah, definitely it's open because when I measured it in circuit, it was measuring a half a meg. And it should be measuring almost a dead short. Yeah, 230K. Yeah, that's toast. Let's find a new one. It's not the exact same value, but it's close enough. It's close enough. It's a fusible resistor, and that's all that matters. Now these ones, we leave them standing off the board a bit because they do get, or they can get warm. I'm standing off the board a bit. Just like the original one, right, was standing up. You know, a good ½ inch. Do the same for this one. Now, if something else causes this to burn up, it's going to burn up right away. We'll find out pretty quick. If I turn it on and I get a raster or a picture or sound or anything, then we know we're good. If it burns up right away, then we have another fault. But the fact that this one here wasn't all burnt up, like I don't see it burn black or anything. I think it probably just stressed out and failed. So we'll pop the board back in, turn the TV on its face here, or on its back, on its base, and for that matter, I'm going to hook up an antenna cable to it and just see whether we get anything happening. How's that for confidence? Okay, are we ready? I can show that. That's mine. Okay, let's just see here. What do these buttons do? Function, color, brightness, sharpness, color, tint, CATV on and off, TV, standard. See if we can adjust the focus on here a little bit. Oh, something else is going wrong with this thing. That's not me doing that. Yeah, I see some ringing on the picture here, you see? On the left side here. Could be a capacitor, it could be the screen capacitor that's gone open, or going open. Now that's typically a high voltage cap. Wonder if I've got one that I've got. I think I probably can. I can probably try bridging this one on, and just see whether that'll fix that problem before I even get into the set to figure out where it is. It's gonna be one of these ones that's somewhere to point. It's gonna be one of these ones down here. And that's a 16 volt. That one there looks to be. That one might be the one. That's a 250 volt. Cap, that one, but let's confirm. I can do it from the back here. I just need a couple jumpers, and the negative side I can put to the ground, any place that's grounded on here, such as that, and the positive side will go to on the back of the picture tube here. And I'm not suggesting to do this when the set's energized, okay? I'm playing with it energized because I know what I'm doing. But on the back of this, that supply voltage will supply the CRT, and it's going to feed the 3 collectors through resistors. So I'm looking on the back here and I can see R961 and R960 are feeding these 2 collectors, and the third collector is this one down here, and it's fed off of R962. So these 3 here should be connected together, and that's the one I want to connect it to. That's just leading down to the board. This is just a quick test. So are these connected together? R961 and what did I say it was? R962. Yes, those are connected together, as is this one here. So this is the line, and that goes down to here. It's even got a white trace on it. That goes down to here, and it also would pick up power from wherever it's coming from, one of these connectors here. Looks like it's one of these ones, maybe that one, H. Looks like it comes along here. It goes up through here, and that's probably a jumper here where it says H. Yep, that's a jumper. So I can clip it on right here. This is the supply. This is the supply right here. So these are all connected internally together. If we look at the meter, H is connected to that, and H here. So that's the supply. So if I take this capacitor and I clip on another jumper here, I'll just clip it right to the resistor itself. As you can see, I'm just clipping it to the leg of the resistor, because these two resistors are connected in parallel. These are the feeder side, these are the sides that go to the transistor, and the other side I can take down to this capacitor. I can show you guys the results. I'll turn the TV around, I'll turn it on, and I'll clip this capacitor in and out, and you'll see what it does to the picture. But keep in mind that I've got about 170 volts in my hand here, so you be careful, because you can get jolted, that's for sure. Okay, let me show the TV screen here, and you'll see the picture will improve when I connect this capacitor up. That's not good. I think I just blew something up. No! That certainly was an electro boom moment, wasn't it? Somehow, a capacitor with a dead short didn't end up in the garbage can. Now I remember, this came out of a power supply that had shorted completely, and somehow it didn't end up in the garbage can where it belonged. So I just blew the TV up. I should be so proud. No, actually I just blew the fuse, so I've got a new fuse in. I've got another cap here. We'll make sure that this one's not shorted. This is a 450 volt, 33 microfarad. It should be more than sufficient. 33 microfarads, there we go. This one's not shorted, so let's take two. I'll connect the ground lead again. We'll turn on the TV. We'll get our picture back after replacing the fuse. And I'm on the wrong channel here, so let's just get it to channel, whatever channel I was wanting it on. There we go. Okay, now we're looking at the picture. You see these lines in the screen here, and it's too bright. So if I connect this up, look a little better. That's the screen capacitor that's failed. See that? Much better. So if you got a screen that's too bright and you've got lines in the picture like this, if I lower the camera down or move it back a bit, you guys can probably see it a bit better. There is the picture. If I go to another channel here, if I can. Okay, my security cameras. See, the picture's kind of washed out and kind of bloomy here a bit. And when I reconnect this capacitor that I've just, with the one that's bad, voila, contrast has come back. And the picture doesn't look to be that bad at all now. I guess maybe it's probably everything's cranked up. Yes, everything is cranked up on here. Sharpness, color, tint, contrast. Let's see if I can adjust the focus now, Because that's what I was trying to adjust before, was I was trying to adjust the focus and it looked like crap. Doesn't look too bad at all now. Right, if I take out that capacitor again, you'll see what it does. See? There you go. That's the screen capacitor. So let's go change it. Incidentally, this being a high voltage charge on this capacitor, it's going to hold its charge for a little bit. If I put the meter on there, it probably still has, you know, a few volts on it. So let's just see what voltage this thing's hanging on to. 172 volts. I would bite if you touch that one. We'll just discharge it first. We'll use the roll of solder to discharge it before I put it in set. If I trace the wires from the back of the neck of the picture tube here, they go down to this connector right down there. I'm sure it's that cap right there. The original one was a 10 microfarad at 250 volts. I'm going to put this 33 in. It'll work just fine. Okay, new cap's in. Let's see how it looks. Okay, it's not looking too bad. That's just my cable.
Entered the office.
Oh, good. Headline news. Yeah, okay.
Bob's money.
That's my cable box connected there. So I would say that this one is done. Now all I gotta do is put a couple new fuses in, because like right now I've just got like jumper wires jumpering the fuse. Gotta put a couple new fuses in, get this one out the door. Okay, there it is, all back together. Thanks for watching. We'll catch you in the next one. Bye for now.